Hey guys, so up till now, in the previous videos, we showed you how to work with 8051 and the software KEIL. So further, we will introduce you to the LCD commands and interfacing with an LCD using the same 8051 and the KEIL software. So before we proceed with the code, let us introduce you to the LCD interfacing LCD command codes. So what are command codes? Basically, command codes are like the commands that you give to an LCD to position your cursor, you to make your cursor blink, to clear your LCD, to switch on your display, switch off your display, shift your cursor right, etc., etc., etc. So move your cursor to the second line and so on. So here are the following hex codes and the corresponding commands how you will pass to the LCD. So before proceeding to the code, you should also be familiar with the three most important pins apart from the data pins, that is RS, RW and enable. Basically, enable pin is here to latch the input. RS pin is to select whether your input will be a command or a data. RW pin is here to select whether the data has to be written or read from an LCD. Similarly, you have a 8-bit data bus which is connected to port 2 of 8051. So now your code begins from here. So initially, before displaying any character to an LCD screen, you need to initialize the LCD with some commands. So here are your commands: 38H, 0FH, 01H, 80H and 6H. So the commands specified are here as follows. 01 is equal to clearing the display of the screen. 06 is to increment the cursor. 0F is to specify that the display is on and the cursor is blinking. And 80H is to force the cursor to begin from the first line. Suppose you want to begin from the second line, you have C0H. H specifies hexadecimal and 38H says that you are using the first two lines of an LCD. So does the LCD differentiate whether the data you're passing to the LCD is data that is to be displayed on the LCD or is it a command? For that purpose, we use RS pin, which is connected to port 3.7. Clearing RS specifies that the data moved to the LCD is a command and not a character to be displayed. LCD read and write, which specifies that whether are you going to read from the LCD or write to the LCD. So currently we will be writing to the LCD, so we need to clear the bit LCD read write. For the data to be latched to the LCD, you need to give a pulse at the enable pin. So for giving a pulse, you need to set enable and clear enable once and give a particular amount of delay. Make sure your delay is sufficient enough for the LCD to latch the data. So let's move down and see what is the delay given in our case. The delay given in our case is FFH once only. So this might vary from one development board to another development board. So you might need to increase your delay in some cases or decrease in some other cases. Similarly, as you pass on commands, this also can pass on characters this way. Instead of passing the hexadecimal value, you can also pass in a single inverted quotes. Since S is not a command and it is a character to be printed, so we need to set the RS. The rest all remains the same, and the following will be printed as we show you in the demonstration. So before proceeding to the hardware, let us see whether the program is correctly running without any errors. Save, build and link. Yeah, so you can see 0 errors, 0 warnings. So here's the development board that we will be using to demonstrate you the LCD, which has an onboard LCD. Here's the code. Here we press the debug button, and here the run button, and you will see Shraddha and 13BC1138 being printed as mentioned in the code. The code will be given to you in the description. Please make use of it. And further, we will be demonstrating you the same on Proteus.
Now let's try the simulation for interfacing LCD in Proteus. For LCD, we'll go to parts. In the keyword section, we'll type LCD and we'll choose 16 x 2 alphanumeric LCD, for which the device is LM016L. Now we go on to dump the code. It is important to give a proper delay in the code for simulation, and always you have to put the LCD in a horizontal manner so that you will be able to visualize the result. Now if we run the same thing, then we can see the characters being printed on the LCD.